Dear students, let us look into a puzzle. In a garden, a swarm of bees are settling in equal number on same flowers. A swarm of bees are sitting in equal number on same flowers. Have you understood this? For example, here we find two flowers and a swarm of bees settle on two flowers. So, when they settle on two flowers, one bee will be left out. When they settle on two flowers, one bee will be left out. Let us see the image. Here, swarm of bees settle on two flowers. Settle on two flowers in equal number. For example, if 10 bees settle on this flower, equal number, same 10 bees will sit on this flower. So the bees are settling in equal number. So here swarm of bees settle on two flowers and one bee will be left out. So after this settling on two flowers, one bee will be left. This is what being said. So, when they settle on three flowers in equal numbers, when they settle on three flowers, two bees will be left out. Let us see the diagram again. Let us see the image again. When the swarm of bees settle on three flowers in equal numbers, how many bees are left out? Two bees are left out. Two bees are left out. When the swarm of bees settle on three flowers in equal number, for example, 10 bees settle on this flower, 10 bees settle on this flower, 10 bees settle on this flower, and two bees will be left out. Two bees are left out. So, when they settle on four flowers, three bees will be left out. When they settle on four flowers in equal numbers, three bees will be left out. Let us see the image again. The swarm of bees settle on four flowers in equal number. Then three bees will be left out. When the swarm of bees settle on four flowers in equal number, for example, 10 bees settle on this flower, 10 bees settle on this flower, 10 bees settle on this flower, 10 bees settle on this flower. So, the swarm of bees, when the swarm of bees settle on four flowers, three bees are left out. Three bees are left out. They don't sit on these flowers. So, what about this image? Let us observe the puzzle again. Similarly, when they settle on five flowers, no bee will be left out. Let us observe the image again. When the swarm of bees settle on five flowers in equal number, for example, 10 flowers on the first settle on the first flower, 10 bees settle on the first flower, and 10 bees settle on the second flower, 10 bees settle on the third flower, 10 bees settle on the fourth flower, 10 bees settle on the fifth flower. So if the swarm of bees settle on 5 flowers in equal numbers, no bee is left out. Do you find any bee here? No, there is no bee here. So no bee is left out. So this is what being said. This is the puzzle. So actually, what is the number of bees? That is what being asked. If there are at most 50 bees, how many bees are there? What is the question? How many bees are there? There are at most 50 bees. At most means the total number of bees can be equal to 50 or less than 50. The total number of bees can be equal to 50 or less than 50. Okay. So how many bees are there? The total number of bees is not equal to 50. You have to find out the number. How many bees are there? What is that number which is equal to 50 or less than 50? How many bees are there in this swarm? This is the question. So let us analyze and solve this puzzle. How many bees are there in the swarm? No, we don't know. So we should assume. Let the number of bees be x. Let the number of bees be x. Then working backwards, we see that x, the number of bees, is equal to 50 or less than 50. Less than or equal to 50. It may be 35 or 20 or 25, whatever it may be. We have to find out. That is the puzzle. If the swarm of bees is divided into 5 equal groups, no bee will be left. Here, observe this last sentence. When they settle on 5 flowers, no bee will be left out. When they settle on 5 flowers, no bee will be left out. If the swarm of bees is divided into 5 equal groups, why should we divide the swarm of bees into 5 equal groups? Let us observe the image again. Here, the swarm of groups settle on 5 flowers in equal number. That is why the total number of bees must be divided into 5 equal groups. 5 equal groups. So swarm of bees is divided into 5 equal groups. No bee will be left. Which translates to, we can express this like this. Observe this mathematical expression. X, total number of bees. We don't know it. That is unknown. X is equal to 5a. We have to divide the number of bees into 5 equal groups. That is why 5 into a. For example, if the number of bees on each flower is 10, for example, 10, 5 into 10, 50 plus 0. So we must divide it into 5 equal groups. That means multiple of 5. This represents the multiple of 5. 5 into, for example, 10. 5 into 10 plus 0. For some natural number a. Here a. For example, if a is 10, 5 into 10 is equal to 50. 50 plus 0 is equal to 50. So total number of bees is 50. So we can express this like this. What is this remainder? 0 is remainder. Here, if the bees are divided into 5 equal groups, no bee will be left. So no B will be left. So remainder is 0 plus remainder 0. 5 into A. If the number of B's is 50, for example, if the number of B's is 50, then what will be A? 5 into 10 is equal to 50. 50 plus 0 is equal to 50. So A will be 10. But this must be true for every case. For example, if the swarm of bees settle on 2 flowers, 1 bee will be left. So if we take 10 and 2 flowers, 2 into 10, 20, 1 must be left. If the total number of bees is 50, then 2 into 10, 20 plus 3, 23 will not be equal to 50. So A is not 10, but you have to find out. Anyhow, we have written this expression x is equal to 5a plus 0 for this sentence. When they settle on 5 flowers, no bee will be left out. So we can write like this. And what about the other sentences? Let us see. If the swarm is divided into 4 equal groups, then total number of bees is x is equal to, if we divide the group of swarm into 4 equal groups, then 4 into b, 3 bees will be left. So plus 3 represents the remainder. So 4b plus 3, what will be the value of b? We don't know. So 4b plus 3 is equal to x. Total number of b is equal to 4 into some number, 4 into b plus 3 for some natural number b. So we have written mathematical expression for the next sentence. Now, when they settle on 3 flowers, 2 bees will be left. Now, if the swarm is divided into 3 equal groups, now you have been familiar with this concept. Now you can write easily. X, total number of bees is equal to x is equal to, we have to divide the group of swarm into 3 equal groups. So 3 into c. C is some natural number c. So 3 into some number plus 2. 2 bees will be left out. So remainder 2. 3 into some number plus remainder 2 bees are left out. So plus 2 remainder. When you add this, you will get the total number of bees. We have written this mathematical expression for this sentence. What about the first sentence? A swarm of bees are settling in equal number of same flower. Okay, when they settle on 2 flowers, 1 bee will be left out. This is the first sentence. When they settle on 2 flowers, 1 bee will be left out. Let us write the expression. When the swarm is divided into 2 equal groups, 1 bee will be left out, and we translate to x. Total number of bees is equal to x is equal to, we have to divide the group of swarm into 2 equal groups. So 2 into some number, some natural number d, 2 into some number plus 1, because 1 bee will be left out. So 2d plus 1, what will be the value of d? We don't know. 2d plus 1 for some natural number d. So if the value of d is 5, for example, 2 into 5, 10. 10 plus 1, 11. Total number of bees will be 11. So the value of d is not 5, just we assume it. Anyhow, so what is the number? What is the number of, how many bees are there in total? So you have to find out the number of bees, total number of bees. Exactly. So that these expression that can satisfy every mathematical expression which has been written here, it must satisfy this expression, and the value of x must satisfy this expression, and it must satisfy this expression, and it must satisfy this expression. It has to satisfy 1, 2, 3, 4. 4 mathematical expressions, 4 mathematical facts. So we have to write expressions like this. That is, in each case we have a positive integer y. In this example, y takes values 5, 4, 3 and 2 respectively. Let me explain this. Here we see we have written a, but actually you can assume it as y. You can take it as y. Not a. Here this is y. Okay, 5 here. 5 has been written, and 4 has been written, and 3 has been written, and 2 has been written. This is y. So positive integer. Here 5 is a positive integer, plus number. Here 4 is a positive integer, 3 is a positive integer, 2 is a positive integer. So here 5, 4, 3 and 2. 5, 4, 3 and 2. This represents positive integer y. What is positive integer y? Here 2, here 3, here 4 and here y is 5. So which divides x? Which divides x and leaves remainder r? This here, observe this expression here. 5 is the divisor, and when 5 divides x, 0 will be the remainder. Here when 4 is the divisor, when 4 divides x, 3 will be the remainder. Here divisor is 3. When divisor 3 divides x, 2 will be the remainder. Here divisor is 2. When the divisor 2 divides x, 1 will be remainder. So 0, 3, 2 and 1 respectively. These are the remainder. Let us call remainder as r. Let us represent the remainder with the letter r. So what is r? R. Here r is 2. Here r is 3. Here r is 4. And here r is here r is 0. Here r is 3. Here r is 2. And here r is 1. So remainder 0, 3, 2 and 1 respectively. That is smaller than y. Observe this carefully. The remainder, what is the remainder? 3. In this expression, what is the remainder? 3. 3 is less than 4. Observe this expression. What is the remainder? 2. 2 is less than 3. Here 3 represents y. So 2 represents r. R is less than y. R is less than y. Here you see numbers and we represent them with letters symbolically. So this is r and this is y. R remainder is less than y. Here y is 3. Divisor. Remainder is less than. Remainder must be less than divisor. That is what being said. In the process of writing above equations, we have used division algorithm unknowingly. I think you have understood This concept we will proceed further in the next video. Okay.